So good morning. Thank you for joining us. We're going to have a look at fall arrest systems this morning with myself, Jamie. I look after the working at height here at JSP.
Good morning, I'm Max. I work in the marketing department and I'm going to be assisting Jamie today.
Okay, so we're going to look at fall arrest systems and obviously what are the differences between these. Start off really, this is no falls week that we're currently sat in, so always have a look at previous stats, unfortunately, which happened within the workplace. So going back as far as 2019 to 2020, unfortunately, there was 111 workers that died that year. They went to work and they never came home. Unfortunately, 29 of those were falls from height. So it's quite a high percentage. We're nearly looking at, well, just over a third of those. Fortunately, falls from height has always been the leading cause. And obviously the other one that you'll see there is struck by a moving object. So that tends to be things that have fallen from a height and obviously have hit somebody else beneath them. So this is 2019, 2020. So we all remember that's a COVID year. So within that, obviously there was a lot less people working. So 111 workers in that period of time is still obviously very, very high percentage-wise to actually what was happening in that year. So what I've done is obviously I've skipped ahead to the most recent stats. And you can kind of see how it's progressed, and obviously it's not good. So obviously that's why we have these no falls weeks. So from 2024 to 2025, fatal injuries actually increased. So actually it was 124 workers obviously went to work and obviously they didn't come home essentially. Obviously the thing that you'll notice is actually falls from height percentage has actually increased in that time. And unfortunately this has been from 2019 all the way through to 2025. It's increased year on year. And as you see, we've got 35 out of those 124, which were related to falls from height. Obviously we're looking at nearly a quarter of those are caused from that. So slips, trips, falls. Like I say, it's why we have weeks like this to try and get around that and try and put the knowledge out there to help people in the workplace. Obviously, the second one that you'll see there is the struck by moving object as well. So with that, again, we're talking about things that falls from height, might hit somebody beneath them, somebody working below. And again, this is why we think about things like tool lanyards and stuff in the workplace, and that's why it's becoming so big in the industry. Okay, so not nice things to show, but obviously it's always nice, not nice, but interesting for you to actually see the facts and figures to why we do things like this. We do these webinars, we do training, etc. to try and put a bit of knowledge out there to help those people get better guidance on working at height. Okay, and obviously the dangers that come with that. Okay, so I know this session is very much focused on fall arrest, but it's always good to kind of get a background for the whole of working at height and how we work. So when we're working at height, predominantly, we will come down to two different things, and that's restraint against fall arrest. Hopefully everybody's heard those terms. As I say, predominantly we're going to focus on fall arrest systems, but so you can see the other side of that to maybe give some guidance to what might actually be out there. Okay, so restraint and fall arrest. Restraint is the most simple form of working at height, and used correctly is always the safest. Okay, so you can see my worker, he's worked out as far as he can there. He's using a restraint lanyard. That restraint lanyard is actually limited into the edge, and he actually can't go any further than that. Okay, so the restraint lanyard has effectively taken the fall out of the equation altogether. So as I say, used correctly, that is the safest port of call. When we're using fall arrest, we're working in a position where we can't actually stop a fall from happening. So there is a fall arrest device that will limit the force of the fall, so it makes it safe on the body. Our bodies obviously couldn't withstand falling on flat webbing. So you can just kind of see that there. I'm not going to drop it on this occasion, but you can see that. Our bodies aren't strong enough to withstand pressure. Okay? So can we bring this on back out? That's okay. So different types of restraint equipment. So this is where you can just drop the slides for a second. So you just hold this in for me. So what we have here, we've got a flat piece of webbing, which you can all see the ring type adjuster. And what this is just designed to be adjustable to make it a case of you can't go any further than once that's adjusted. Okay, so I can't actually leave the screen. All right. So I've got Max as my anchor point. I can walk as far as here, and I can't go any further than that. most common use you'll find with these is within cherry pickers. So we all know what a cherry picker is, a boom lift. The arm will go up in the air, any movement to the boom, and it creates a catapult effect within the basket. A lanyard like this will just be designed to keep them within the basket, straightforward as that. And again, if we think about a roof edge, this will adjust as far as the roof edge, but you can't go any further than that, okay? So we can bring the slides back up. So obviously you have different types of restraint. Obviously we have the fixed restraint, which is just a length of rope. Obviously that will work, but you obviously would have to do your risk assessment to make sure what length of rope you actually need for the job. Obviously adjustable is always better because it means you can take it job to job and you can adjust it then accordingly as where you might need different lengths, okay? So obviously you can think about that. So on a roof edge there, we've got the worker, he can go as far as the satellite dish, but obviously the restraint lanyard will stop him going any further than that, okay? So obviously he just needs to think about the working area of where he's connected that to. So obviously it's going to limit how far he can go. Go as far as the satellite dish, do the maintenance, and it can't go any further than that, okay? Obviously you have to think about the length, as I said, so when you think about fixed lengths, that obviously can be limiting and obviously it also can be dangerous. If it's not adjustable, there's a chance that the lanyard you've got might be too long, all of a sudden they're now at risk of a fall. Also, on the flip side of that, they might have a lanyard that's not long enough, so they can actually not get as far as they need to go. Again, so if you've got to the roof, you've got your 30 meters up in the air, you've got your lanyard, you've connected it on, you've walked out, but you can't actually get as far as needed to do your job. That's obviously just as bad as potentially having a lanyard too long, okay? So your adjustable always takes care of that scenario. Okay, so obviously that's restraint. So fall arrest. Obviously I mentioned fall arrest devices are there to limit the force in a fall. Okay, so on the screen there, and I'll show you these live in a second. Obviously we have an example of a fall arrest lanyard, a self-retractable lifeline, and a rope and grab. We may have seen these before, we may not have. Basically, fall arrest lanyards, you get them in all different types. So that particular one is just a standard rope, but you might have a webbing, you might have an adjustable version, you might have a sharp edge version. But most of the time, the max length will be 2 meters, and you might get them as short as 1 meter, depending on what you're doing. Again, adjustable can kind of take care of that in that scenario. Obviously, the self-retractable lifelines, obviously these are quite large blocks. They can also go down to mini blocks. And then obviously in their rope and grab again, all different types to limit force in the fall, okay? Again, we'll show you the differences of those in a second. If we can just drop the slides so I can just show you the products themselves. Just hold that in for me. So again, obviously, fall arrest lanyard. Obviously, I mentioned before with the restraint lanyard, our bodies aren't strong enough to withstand that. Chances are our ankle points won't be strong enough to withstand that. We're talking about 18 tons that's going to go through the body, something like that. Realistically, what our ankle points tested to a maximum of 12. So again, if you just fall on flat rope, it's not just a case of our bodies won't stand it, it's actually the force that the ankle points themselves won't stand it. So what we have in there is we have a shock absorbing element, which you can see here, and I'll go on to explain how that works and what that does in a minute. Okay. The different types of blocks we have. So again, if you can hold this in for me, we have a larger block, so you can all see that there. Obviously, we use the booms freely. Okay. You also have the mini version of that, so you can hold that for me. Again, user will move freely. Okay. And the other one, obviously, we have rope and grab system. So what you see there, so that will go up and down the rope. Okay. And obviously, it's going to lock up at certain points and explain again how that works in a minute. But just to show you the actual product itself. Again, so if we could just bring those slides back up. So obviously we have 3 different types there. I guess the question is you're thinking about is why do we have 3 different types? Really it's to do with how far the user's going to fall, okay? Also we think about with fall arrest, with the restraint, are there scenarios that you might use one, that you might use the other one? Again, it might be certain situations that you might need to use both, okay? But the way the fall arrest lanyard works, obviously that shock absorbing element that we saw, that's designed to obviously take the force of the fall. Obviously the way that works is that shock pack will start to deploy. The way it's, you basically got loads of webbing that's all being contained, sewed together and pressed down into that little pack. And what happens is on impact, that impact will start to tear that webbing apart, and then obviously you've got longer length of lanyard to think about. Okay. Just have a little video here. This is going to show you the difference with in the same working environment where you might need to think about restraint or where you might need to think about fall arrest. Okay, so as you imagine, I get asked on a daily basis, I'm working in such and such area. Do I need to use restraint? Do I need to use fall arrest? We've got a working scenario of potentially, depending on where you need to access, to what actually you need to use. Okay. So I'll kind of explain it as the video is playing. We can just make sure the sound is low, so it's not. So first scenario, we've got restraint here. Okay. So you can see that you can safely get to either edge of this working roof. We can call it that. Okay. So obviously I've adjusted my lanyard. I can get to either side correctly. If you can just pause it there for a second as well, Will. Okay. So I can get there either side correctly. Did anybody notice where you couldn't get to? So say, for example, I want to access the corner of that roof. All right. All of a sudden, I could fall off at either end. Okay. So the corner itself, you could step off. That's what essentially would then put you in a fall arrest situation. Okay. So again, if we could just carry on with playing of the video. So I can see some questions flying through, which is great. I will answer all questions at the end. We'll have a little bit of time for that as well. So feel free to put any questions into the chat. We can go back to those. Okay. So let's say I need to get to access to the corner of the roof. I know I need to do some maintenance. If you think about potentially a satellite dish again, all of a sudden I might be exposed to falling over at either side. Okay. And because I'm exposed to falling over either side, I obviously need to think about the fall arrest element. And you can obviously see from the diagram what we also need to allow for in that scenario. Okay. Okay. So I've also, just to put it into perspective, I've got a video here of the difference with falling on a restraint lanyard versus falling on a fall arrest lanyard. There'll be two drops. The first drop will be, dummy will be dropped in the test lab. He will be dropped on a restraint lanyard, and you're going to see actually how much force that puts through the body, how much it kind of impacts the mannequin. And then the second drop will be the difference with actually falling on a fall arrest lanyard. Okay. Apologies, the commentary will be in American, but we've got the British. So you can obviously see that fall on the falls there is the restraint lanyard. You can see obviously the impact on the neck. Obviously that put 22 kilonewtons through the body. Okay. I mean, as I say, our anchor points are tested to 12. So the chances are whatever that is actually connected to in real life situation is actually not going to hold. So the second drop is obviously with the fall arrest lanyard, and you can obviously see how that catches. Obviously the mannequin hardly goes anywhere, and we're then limiting that to below 6 kilonewtons, which is the number. That specific drop you can see at 3.7. Okay. So obviously what impacts our falls when we're thinking about fall arrest devices? Okay. So maybe we might have all heard of fall factors, we might not have. I won't cover too much in detail of how we are thinking about it, but essentially we're thinking about where we are connected. Okay. So fall factor 0 is what we call the safest port of call. That is connected above head height. Obviously you can only fall the length of the lanyard before it catches you. Okay, that's the key wording that we have to think about there. So fall factor 1, that's when we're talking about connecting at waist height. So again, we think about we're connected at waist height, you've got to fall the length of the lanyard again before it's going to catch you. So you're adding on at least another metre before. And finally, the worst case scenario is a fall factor 2, which obviously you connect at foot level. So you've got to fall the whole length of the lanyard before the lanyard actually catches you. Okay. So if we can just drop the slides again for a second. Easiest way to show you this is if you just hold this end from here. I'm going to connect up head height as high as I can. Max can only fall the length of this, okay? When we're connected here, so unfortunately he steps off, he's going to fall this whole length here. So we're adding on another metre of that forward before it's going to catch him. When we're connected obviously down here, unfortunately he's going to fall this whole length before it catches him. So we're just talking about how much force that's going to put on the body, okay? Hopefully that makes sense. And obviously we'll go into a little bit more detail on that. We'll just put those slides back up. Which is nerves. Okay. Okay. So obviously we're talking about ground clearance, and we're going to talk about in this scenario of the worst case, how much distance do we need to allow if we've got a 2 meter full arrest lanyard that's connected at foot level. So the way it's worked out is you account for the lanyard, you obviously account for that shock pack, which we allow for 1.75 meters, if you didn't know. So obviously that's quite a length. So we're only talking at the length of the lanyard again, contained within this. Okay. That will deploy. We then obviously need to think about the height of the user, and then obviously we'll also want a bit of safety clearance at the bottom beneath that. So once we add it all together, we're talking about 6.75 meters of ground clearance, which is a long way. Long way. As you can imagine, we have people using these devices all the time. They might be 2 meters up, they might be connected at the feet, and obviously they're going to use, they're going to hit what's beneath them before the lanyard can actually do what it needs to do. So obviously you can see that there. Obviously point A, we've got the length of the lanyard, 2 meters. Deployment of the shock pack, max 1.75 meters. Obviously, if you think about the length of your lanyard, if it's any shorter than 2 meters, so if it's 1.5, obviously you're just taking a 0.5 off the final number. So distance between the anchorage point of the harness and the feet of the user. Okay, so obviously that's just talking about the user's height essentially. Again, we allow an average of 2 meters. It's not that many people out there that's all. However, it's good to obviously overestimate where we're going to need to. And obviously we always want a bit of safety clearance beneath it to finish it off, because the last thing you want is to take a fall 6 meters and then finish up 10 centimeters above the ground. So we always allow for an extra meter for that. Okay. If we could just drop the slides for a second. What I have here is I've got an example of a lanyard that obviously started out at 2 meters. It's had the fall. Okay. So obviously from there you can see how much of that pack has come away. Okay. Try and tackle that for a second. So yeah, well obviously with the pack here, what happens is where that's all sewn together, the user takes the fall, that tearing effect is what then deploys, and obviously we've got the shock pack here, which obviously you can then see starts to thread. As you can imagine, it gets quite a length. We're talking about 3.75 meters to a lanyard. All right, so we can put the slides back up. Okay, so obviously you'll see the 6.75 meters. Obviously it's quite alarming. The most common use for these really is you see scaffolders using them. I'm sure we all have. What's a scaffolder work these days between platforms? Yes, they might go up 20 meters up in the air. However, the platform that they've built beneath them is roughly 3 to 4 meters at max. So chances are they're using these lanyards. If they actually ever have a fall, they're going to just hit the platform that they've actually built beneath them, which is obviously no good. Obviously, I'll start to look at that. Okay. Other things to think about is obviously what we're anchoring to. So you'll see a lot of people on site, they don't have the anchorage, they don't have the slings that they can connect straight onto. So they'll introduce something that they call a horizontal lifeline. Okay. So this video here is just kind of going to show you and exaggerate the fact that you have to take into account when using a full arrest lanyard with a lifeline. This lifeline will span up to 20 meters in length. So if the user has a fall, there's obviously going to be some slack in that line, and obviously that fall distance will then potentially increase even further. Yeah, and I'll kind of explain that as we go through. Hopefully the video is playing well, not too laggy. Okay, so we've got our crates in, comes to the next day, the user's climbed up with his lifeline. Okay. Obviously, we've connected that in. And again, while we're thinking about this as well, thinking about the lifeline, we're thinking about where you can't actually anchorage. So on top of the crate here, for example, there's not really much you can do with the top of a crate, is there, in terms of anchorage? Because there's not really much there. You can only tend to use the corners. So why you might set up a lifeline is so you can actually get across either side of the crate correctly and safely. So obviously the users obviously adjust the line, made it as nice as tight as they can. But even when you make it as tight as you can, there's still going to be some slack, obviously, in the event of fall. Okay. So this is just obviously a 5 meter span, so this is quite small in this kind of example. But even that, you can kind of see how much slack we've got. So in that scenario, we've added 0.83 meters onto that, which when we think 6.75 meters, we're now into the realms of verging on 8 meters in total. Okay. Again, with these type of lifelines, if you can get away with using restraint with them, again, it's always safe to do so. So now obviously we're going to extreme it to the absolute max. So a 20 meter line, the user steps up, the user's had a fall, obviously the deflection's happening. We've added on 2.44 meters to the total length. So we're already at 6.75 meters. We're getting close now, aren't we, to 10 meters total, all right? So these devices tend to be used where singly for 4S, and then when you're in a restraint scenario, you can obviously have 2 people at a time on that, okay? Again, just something little to think about. Again, it's a lot of stuff to think about, I appreciate, but unfortunately every step we take, we introduce to the 4S system, we just have to take into account how much full clearance that potentially is going to add, okay? So we have a real good tool on what we call our JSP Go page, okay? So embedded in there, we have all the videos. So we have harness fitting videos. Obviously, we have the videos that you've already seen today. But we also have fall calculators. And depending on what you're using, this will give you a rough idea of how far the user will fall, depending on where they're anchored, what they're doing, potentially how heavy they weigh, okay? So on the JSP Go page there, you can click onto the red calculator. That will bring up the numbers. You type those numbers into how you're going to be working day to day, and then I say the calculation will give you a rough idea of how far that particular user will fall. Okay, obviously it's not going to be exactly perfect, but it's going to put you into the realms of, okay, roughly this person's going to need 5 meters of full clearance. The calculator has said that their maximum is going to fall potentially 4 meters. So you know in theory that you've got a meter to even play with there, so you should be good to go. Okay. So the one obviously we have standard with just the 4S lanyard, and then obviously we've even incorporated a 4S calculator with the horizontal lifeline as well. So say even if you have a little bit of time and you want to have a look at that, you can obviously see the differences with how they work between the two. Okay. Obviously you're always going to fall further if you're connected to the lifeline purely because of the slack that's going to occur with that lifeline. Okay. So obviously 4S distances. So this is obviously when we're starting to talk about the other products, right? So a self-retractable lifeline, that is used, what we call them, to limit the distance in a fall, okay? So obviously when we count our ABC with the 4S lanyard, we're only looking at an A and B when it comes to the 4S block. If we could just drop the slides for a second. Obviously when we've got this lanyard here, if you hold that in for me, the user's moving freely. But what happens is what we call it's like the seatbelt effect. So locks on, okay? That's then caught the user pretty much instantly. Obviously it greatly reduces the fall distance. I've fallen on one of these myself. I fell about 1.5 meters. I can tell you that was far enough. Blink of an eye, you're just dangling there and you don't really know what's happened. I don't think any of us could really imagine falling 6.75 meters in total, what that would do to us. Panic that would potentially set in, how far you've fallen, obviously it is going to hurt as well. Ultimately the devices it's going to catch you and save your life when it's used correctly. However, there's still going to be a bit of injury to the user. Think about, obviously, when we're reducing that fall distance, greatly reduces obviously the risk of how hard that's going to hurt, okay? Obviously, the less they fall as well, the easier it is to then rescue them. So we think about our rescue plans, how we're going to get the user back up if they've fallen. The less they've fallen, the easier it is to be able to save them. Okay. We can just put those slides back up for you. Obviously, that's the same with all the blocks. So whether they go small or whether to big, we are allowing a maximum of 3.5 meters. But really, that's for blocks that have the incorporated shock absorber to them. If we've just got a standard block that's above the head, no shock absorber, you're probably really looking at 2.5 meters total. Okay. Obviously now with these, this is connected above the head. This number is taken purely on if you've stepped off directly beneath it. Chances are we're not going to be directly beneath it. Okay. So with the devices above your head, you have a 40-degree angle max, and really what we're allowing for there is obviously we have to think about the pendulum effect. When we think of gravity, we think of physics. It's always going to swing you back to the middle. So my user there, he steps off to the side there. All it's naturally going to do is going to swing him past the point of anchorage until it arrests him into the middle. Okay, so obviously if you've got a wall beneath you, there is the risk that the user can obviously go into that. And obviously if you stepped out, it's going to lock off at that point. So potentially you've added on 2 to 3 meters distance to that fall. Again, obviously you need to take that into account as well. Okay. Obviously you can see the key point there, to try to keep it as simple as possible to make it understandable. So the position of the user is obviously number 1. He's then had the swing fall, which is number 2. And then obviously we've got a wall set up there on the left-hand side, because obviously he's going to try and actually swing further past that, but because the wall's there, obviously he's gone straight into the wall. Okay, so obviously you need to think about that in your risk assessments. Again, we've got a little video together to kind of help show that. So again, it will show you the distances where you fall directly beneath it, and obviously also where you fall to the side of it. Okay. So obviously green is obviously the safe zone. We've accounted for, we've stepped up. Unfortunately, we've stepped off the train. The block's pretty much locked instantly, and we're pretty much dangling where we could actually just step back onto it if need be. All right. Chances of that happening are slim. So in this scenario, obviously I'm now down. I need to do some maintenance on top of the train. I've also added a meter of full distance to that. Okay. Okay, obviously still we're safe. Now obviously when we start to go at risk, it's where we start to walk out, and obviously thinking about the pendulum effect, walked out, I think on this occasion further than the 40 degrees we're allowed, which is obviously going to put some serious risk. Obviously trains aren't that high. Obviously the reason we've used the block is to obviously limit the full clearance as much as possible. By going too far out, all of a sudden the length of the wire is too long, fall off. First of all, it's going to swing us into the racking, but chances more of it is actually just going to go straight into the ground once it's locked, and obviously the length of that. Okay. So obviously then when we think about walking out to a safe zone, again, max of 40 degrees. You step off, you're still going to fall off, you're still going to swing, but at least we've accounted for that safe zone that you can actually fall into. Okay. So without colliding with anything, without having any issues with going to the ground. So every time you step out a little bit further on the angle, you're adding that to the potential fall distance. Okay, so if we're allowing a max, say let's say 2.5 in this example. Let's say I've worked out a meter to the side of me. All of a sudden, I need to allow 3.5 meters. Okay. And again, on JSP Go, really, if you ever any doubt, have a look at these tools because they are really very good. Depending on if you're using a vertical block, depending on if you're using a horizontal block, you can type the figures in and it will give you that rough guidance of how far that user is going to fall. And obviously in this scenario, we'll even take into account the angle. So obviously, as provided we're less than 40 degrees, again, even if you're using a horizontal version of the block, you can obviously, that 40 degrees goes out the window to a degree, but you can still type your figures in, use these numbers, and it will give you that rough guidance that you can obviously then use as an estimate when you're working day to day. Okay. all very, very good tools to have. I'll be honest, it's the first time I've actually seen these type of calculators live on a website where you can physically type the numbers in and it will give you that full clearance there and then. As I say, this is just JSP Go, JSP.co.uk. There's nothing difficult about it. It's all there for you to use and you can use it at any point. Okay. Obviously, I've got a couple of bad examples with 4S blocks. Obviously, even though they are deemed to be used and be safer, because obviously in full clearance, you still need to obviously use them safely. So in the two examples I've got here, we've got the two hangman systems. If I concentrate on the guy that's on the rooftop first though, so he's obviously not even got to where he needs to work yet. Realistically, he's going to need to get to the edge of that roof, put the flooring down. He's nearly at an angle of 40 degrees already. So the hangman system isn't high enough, so the block can't be high enough, so the block itself is only working, and it's going to be working at a bad angle. Okay. Obviously, with these blocks, you have standard vertical use blocks, and you also have horizontal use blocks. The horizontal uses are fairly new standards to the industry, and with that, a lot of people were using old blocks because at the time when they purchased them, they were told these blocks can be used horizontally, and as per the new standards that have come out, they actually can't. Okay, so there's also something to bear in mind. So yeah, the person on the left is going to be above the 40 degrees. He's also added an extension to it. If he actually has a fall off the side of the building, there's obviously got to be a lot of swimming to get that back towards the hangman. Okay. Obviously, the guy on the right, top of the lorry, probably can't pick it up, but he's got two blocks there. Okay, it's two hangman systems, and he's walked the entire length of that flatbed lorry. From the blocks, you can actually see that he's connected to the furthest one. Okay, so you can see that that block is kind of moving in a horizontal position because of that, because obviously that's where he's connected. He's walked the length of the lorry, and obviously the cables then pulled that block to him. So if he steps off that, or if he falls off that lorry, that length of wire is now going to be close to 10, 15 meters, depending on the length of that lorry. I mean, what's he got beneath it? 2. Okay. So it's really stuff that we need to be thinking about. If he had connected to the block that's closest to him, he would be absolutely fine in this scenario. But clearly he's just gone, okay, I've connected, I can't be bothered to connect to anything else. As I say, that length of wire is going to be very, very long. If he falls off at the end there, he's going to hit the ground before the block can actually do what he needs to do. Okay. So hopefully that will make sense. I apologise, I've slightly ran over the half an hour. Obviously, if you ever want to contact us, as say Jamie, JSP, I tend to look after all the work at height, so please come to me if you need any help. Right. Other than that, if there are no other questions, I will leave you all to have a lovely day.